Hey guys, welcome to lesson 7.2, and we are going to be talking more about square roots, cubed roots, all that good stuff. So let's begin. So when you have fraction problems or division or however you want to think about it, it can either look like this or like this. So what you'd want to do is like, what would be most beneficial to you? So this one is actually going to be more beneficial if I separate it into two parts. Because 4 9ths, that's not gonna, like, I can't simplify that as is, but I can take the square root of 4 and I can take the square root of 9. So I ended up with 2/3. This one, I can't really, I mean, I could simplify it, but I think what's going to be easiest if I look at it as 20 divided by 5. So notice I'm putting it more into like this form here. And 20 divided by 5 is 4, and the square root of 4 is 2. So in the last chapter, we would, split things up where it looks like this, but know that you can also go the other way. So 5 times 125, we can squeeze that underneath the same radical, and that's 625. And the square root of 625 is 25. Okay, so this is something that students really get messed up on. So when you have an expression, so let's say like x to the 3/4 power, this is going to be your exponent, and this is going to be your root. So the root, think about roots in the ground, they always go on the bottom. So if I were to rewrite this, it's going to be x to the 3rd power, and then the root is going to be the 4th root. You'll also see it written like this with that 3 on the outside, and that's okay as well. You'll see it both ways. Okay, so let's get to some problems here. So I want you to convert this to a rational exponent. So this is going to be an exponent form. So there's my exponent is going to be 1, and my root is going to be 7. So it's going to be 9 to the 1/7 power. This is the same thing as saying -1 times the square root of 7. And something else, the square root of 7, there's no number. Square root, the root is 2. So it's going to be -7 to the 1/2 power. Okay, so now for these radical form, that's going to be that root. So it's going to look like this. So this is going to be our root. This is going to be our exponent. When it's a 1, you do not have to show it. So it's just, this one is just going to be the 5th root of 3. This one, notice how it's in parentheses versus this up here that it's not in parentheses. So we are taking the cubed root of that negative as well as the 5. Okay, so we talked a little bit about the order of operation here. And so let's go back and just kind of review some things that you should know that may be forgotten. So remember, when you have a negative exponent, it's not happy where it is. So if it's on top of a fraction, it goes below the fraction. So also, so it's going to be 1 over this. But also, I'm going to put this into radical form here. So I have the cubed root of -8 to the 1st power. So I'm just going to leave that alone. So let's kind of clean this up a little bit. So if I had this, the cubed root of -8, remember, cube roots, you don't have to worry about having it be a positive. So -2 times -2 times -2 gives me -8. So the cubed root of -8 is -2. So my final answer is -1/2. This, let's go ahead and kind of rewrite this in radical form so we can kind of get our minds wrapped around this. So the first thing that's jumping out at me is that the 6th root of 64, if you look at your chart from the other day, that's going to be 2. So I have 2 to the 7th power is 128. And if we went the other way, so let's pretend like you didn't do it that way and you did 64th to the 7th power, that is a huge number. And so maybe some of your calculators will shut down. So it like to me, it's best to do this first and then this because it gets that number smaller. Okay, so notice how we have a negative. So the first thing that's going through my mind is it's going to be that. And so I'm going to write this in radical notation just because we're used to it. So the first thing I'm going to do is I'm going to take the square root of 64, which is 8, and 8 to the 3rd power is 512. So that's going to be my final answer. Okay, so think about, please excuse my dear Aunt Sally. So we don't have any parentheses, but you have to do exponents before you do this multiplication. So this is why I look at this. We've got to take care of that. And this is the same thing, just like I said before, it's like being multiplied times -1. So I really don't care about that negative right at this very moment. So, so I'm just going to kind of cross this out and let's focus on this. So this negative in the exponent says that it's going to go in the denominator of the fraction. So it looks like that. And so then I'm going to multiply that by that -1. Here, let me back. So that's where that's coming from. Okay, and if I rewrote this in radical notation, it's going to look like that. And the 4th root of 16 is 2. So again, I'm going to have -1/2. Okay, so we've had this before. When you have the same base, you can add the exponents. The biggest mistake I see is that people will put 9. That is not true. So think about if I had like x to the 2nd times x to the 3rd, that would give me x to the 5th. So notice that these don't change. Same thing with this 3. That doesn't change. So it's going to be 3 to the something power. Okay, so on your calculator, or if you're doing it by hand, you have to add these fractions together. So 1/3, that's the same thing as 2/6 plus 1/6 is 3/6 or 1/2. So that's going to be 3 to the 1/2 power. Ugh, I don't like that. That made it ugly. Or you could write it as the square root of 3. So please feel comfortable with seeing it either way because you're going to see it both ways. Okay, something else that we learned is that when you're dividing, you subtract the exponents. So really I have 8 to the 1/3 minus 2/3 power, which is going to give me 8 to the -1/3 power. And so that is the same thing as 1 over 8 to the 1/3 power, which is the same thing as the cube root of 8. And I can take cube root of 8, that is 2. After all that, my final answer is 1/2. Okay, so we have lots of things going on here. So if you can, I would suggest simplifying this as much as possible. Sometimes you can't, but I would try to get that down as much as I can. So really, notice the variables I can't really do anything with, but I'm looking at that right there. So can I take this 27 going to 500? I do not know. No, it does not. But do they have something that will go into both of them? So let's, yeah, so I'm not having any luck of something that would be good. So what I'm going to do is I'm going to go ahead and separate these. So it's going to look like this. Because what I'm seeing is that I can take the cube root of 27. I definitely know that. So let's start here and see what happens. So 500, that is the same thing as 125 times 4. So I can take the cubed root of 125. I can't take the cubed root of 4. Let's do as we did before. Okay, so cubed root of 125, that is 5. I can't take that one. So this one, 18 divided by 3, that's x to the 6th power. So that comes out evenly. 3 goes into 10 3 times. So I'm going to have y to the 3rd power with a leftover of 1. So that's what's going to go on the inside. So I have y to the 3rd on the outside. So let's see. Let's take the cubed root, and what do I have? I have a 4 on the inside. And what else? I have a y on the inside, and that's it. So see if you can do this bottom one. So this ends up being 3z to the 9th on the bottom. Everything comes out perfectly. And if you could simplify something, do it, but like there's nothing we can simplify. So we're done. So go through that same process and see this one. And that will be our last one. Something else I like to do is like a lot of times you'll see me, I'll use arrows. So like the 4th root of 16 is 2. That comes out. 4 goes into 18 4 times. So I'm going to have x to the 4th, and then I'll have x squared left over. And then 4 goes into 12 3 times, so y to the 3rd, and I don't have anything left over. So on the outside, I have 2x to the 4th, y to the 3rd, and on the inside, all I have is x squared. And so then I'll do the same thing for the bottom. So try that. Okay, and you should have gotten 5z to the 6th on the bottom, and we are done.